Good morning, everybody. This is Brent with Lykins Motorsports. Still have a touch of the Ohio Valley crud this morning, so my voice sounds a little bit deeper than normal. But for today's episode, we're going to go over this small block Ford, and this is not just any small block Ford, but this is a 302 tunnel port. And did a few videos about this engine in the past. We're going to do a one and done video with this engine. This engine belongs to a customer of mine out west, and he does a lot of road racing and has a lot of vintage cars, a lot of cool stuff. This tunnel port motor is certainly one of those cool engines that he has. So yeah, let's delve into this and get right into it. So the small block Ford tunnel port stuff showed up in 1968, and it didn't last very long. We'll probably get into a little bit of that here in a second. The reason why it didn't last too long was the bottom ends of the engines just couldn't withstand the amount of RPM it took to really take advantage of these cylinder heads. So if you're familiar with a lot of my tunnel port FE stuff, the ports are just huge. And we do a lot of good on smaller engines to close that cross-sectional area. The ports on the intake ports on these 302 tunnel port heads are equally as big. We have a very small engine, so they were trying to turn these things sky high, and in 1960s, the amount of parts and technology to support that kind of RPM just wasn't there. We can do that kind of thing now, but back then they couldn't do it. So they quickly abandoned the 302 tunnel port stuff in favor of the Boss 302 engine program, which was a 302 block essentially with Cleveland heads on it. So the engine still had fairly decent sized intake ports, but the way that the head layout was, it kind of favored more for performance, and it was very successful in Ford's Trans Am racing and other, the street programs even. So as is my seems to be my tradition on these kinds of videos, we're going to start off with the block. So let me show you what the block was and the condition that it came in when I received it. So here's how I received everything. That is a complete tunnel port race engine on this side of the picture, including the block and including it's a special block because the race heads oil up through the cam bearings like an FE would. So it takes a different block than the traditional heads. On the opposite side of the picture that you just saw there is the block that we were going to use for this street build. So it's a 68 early Boss 302 block. And you can see the condition that it was in when I received it. Very dusty, very nasty. Needed a lot of work. A lot of spider webs and that sort of thing inside the block. So what we usually do in this situation is take the blocks. Well, I pretty much do this to every block that I use, but we put those in an oven. They're baked and then they're tumbled and basically shot peened, and that makes the blocks look pretty much brand new when they come out. That allows us to take a better look at things, to do a crack checks, do pressure tests, see things that have been hidden by the dirt. And as you can see there, it's a 1968 Boss 302 block. Boss 302 block evident by screw-in freeze plugs and 4-bolt mains. It's a C8 engineering number, but you can see by the date code up there that it's a 69. It was cast in 1969. B27 date code. And that's what the blocks look like when they come out of the oven and they're shot peened and they're fully machined. So we did our normal battery of machining operations, square deck, a line honed with ARP fasteners, cylinders bored and honed, at least honed, if not bored. On blocks where the cylinders are thin, we usually try to hone just to get as little material out as needed. So if you look at that thrust bearing, the number 3 main saddle, you can see that it had been factory brazed. So apparently there had been some issues with the mold or with the casting out of the mold, and they brazed that up, and we thoroughly checked that over, couldn't find any issues. It line honed well, the mains, the sizing stayed well, so everything proved to be good to go. Also see where I had massaged the oil pump flange hole. There's the block with paint on it, and ready for bearing clearance checks and cylinder wall, piston to cylinder wall clearance checks, cam bearing installation, that sort of thing. Here we're looking at the front of the block. Steel thrust plate, since we're using a billet steel camshaft. All screw-in freeze plugs. Your small block Fords already have those in there, so you don't have to tap any of those holes. But you can see everything's really clean from the bake and tumble process. Here's the bottom side of the block. Again, you can see the steel thrust plate, the paint on the block. The Boss 302 main caps are pretty beefy, so you can see just by the thickness of that front cap how wide they are. 4-bolt caps on the middle 3. We used ARP studs on the middle fasteners and the factory Boss 302 bolts on the outer 4-bolt cap fasteners. Pretty beefy setup. Hard to tear one of these blocks up. I think by far this is probably the stoutest factory Ford 302, 289, 302 block that Ford made. Then another shot of the block with all the machine work done, the paint, thrust plate, camshaft. Camshaft was one of my custom hydraulic rollers, specifically designed for these tunnel port heads with the large ports. I've kind of walked myself into some successful cam grinds with the small engines with the big intake ports. So for sure needed one in this application. We really had to balance the amount of overlap with streetable performance, since overlap helps out with these big intake ports. So stepping up to the cylinder head side of things, here's how the heads came in. These are the street heads. You can tell by on this angle for the picture, you can tell by the way that the rocker arms are made. That's a stud mounted rocker arm setup. Push rod tube going down through the intake port. Very large intake port for a small block Ford head. Factory valve guides there. We changed those out. We'll show that here in a second. So one of the things I did was to put the cylinder head on a flow bench and see what the heads flow on the intake side and on the exhaust side. Didn't really have a port entry plate for a tunnel port, so we used some clay and shaped that a little bit. And Superflow 600 to see what the intake ports and exhaust ports flow. So what do you think that they flow for a street head? If you look at some of the Ford stuff, the factory documents, they show 370, 380 on the race stuff. What do you think the street head flows? I'll give you a few seconds to think about it. 257 CFM at 700 lift with 155 CFM on the exhaust side. It's with a 1.9 intake valve, 1.55 exhaust valve. That calculates out to about a 60% intake exhaust flow ratio. So in the general scheme of things with small block Ford heads, 250 CFM was a nice head. When most of the factory 289, 302, 351 heads are down around 170, 180, 190 CFM. What puts a little bit of hurt on this is, yeah, the flow isn't bad at 250 CFM, but it is a huge intake port. When you have a big cross-sectional area and the velocity just isn't that good. So that's what the intake port on the intake measures, 2 inches and 70 thousandths. And yes, my dial calipers are not made by Starrett. You wouldn't believe the amount of insecure armchair engine builders that like to pick out everything that they can against me. That's insecurity right there. So on the cylinder head side, normal gamut of machining processes, valve jobs, surfacing, that sort of thing. We did not bake and tumble these heads because they had some sort of epoxy on the underside. I don't know if that was from the factory or what, but we didn't want to disturb that, so we just did a glass bead. But brand new Ferrea valves. I think they were Ferrea. Either Ferrea or SI. It's been a little bit. Bronze valve guides, so we can use the Viton valve seals easily and replace worn out valve guides. So the assembly process went towards a beehive valve spring for this hydraulic roller camshaft. So comp cams, beehive valve springs, locators, tool steel retainers, and steel locks. As with everything that I do, each install height is measured and adjusted if necessary. All the spring loads are checked and adjusted if necessary. Then we'll have a close-up of the assembled head. Conical springs look a little bit, conicals and beehives look a little bit different than a normal spring. So on this next picture that I want to show, this is a view that very few people have seen in their entire lives. The underside view of a Boss 302 block with a Ford 302 tunnel port street head bolted to it. So on some combinations, I like to put the head on, flip everything over, and see what kind of area I have around the valves. See if there's any shrouding issues or anything like that. So you can see it's a wide open. I think this is a 4060 bore or maybe 4070, I can't remember. You see how thick that main cap is there to your right. And then custom billet core hydraulic roller camshaft. Cylinder skirts had already been notched. I've seen a lot of Boss 302 blocks that have those, but plenty of meat there. Here's another picture that you don't normally see, a Boss 302 block, ready for tunnel port heads on the left, and almost a complete 289 engine for a Shelby Cobra replica on the right hand side. Had two small block Fords going on concurrently. Decided to take some pictures. Camshaft degree process. Always degree your cams. And it's not a factor of, hey, they ground my cam wrong, or I want to make sure that they didn't grind my cam wrong. You have three variables: the crank, the timing set, and the cam. You want to make sure there is no tolerance stacking there. Racetech pistons for this one, we used an eagle crank and some scat I-beam rods. Custom forged pistons from Racetech with a metric ring pack to bring some of this stuff into the modern world. Degree the cam, check piston and valve clearance. I like using clay. It gives me an idea of what the radial clearance is as well. There's other ways of doing piston and valve clearance checks, but this is what I rely on the most. And then another shot degreeing the cam with that Racetech piston in there. Coy's timing set with a steel cam gear, double roller, and a one-piece fuel pump eccentric. Intake manifold was a factory Ford intake for the 302 tunnel port heads, 2x4. Had this one vapor blasted by Houston Vapor Blasting. If you need something cleaned up and made look brand spanking new, search old Bobby up, Bobby Crumpley, Houston Vapor Blasting. He'll make it look brand new for you. Assembly process started. Factory cast iron water pump replacement. Factory harmonic balancer we reused after checking to make sure the elastomer was good. Carter fuel pump. Guide plates, rocker arm studs from Comp Cams. Wix filter. Comp Cams roller rocker arms. Morel hydraulic roller lifters, link bar lifters. Here's a shot from the top. You can see how big the intake ports are from here. It's a good picture. Trend push rods. This is all quality stuff that I use in all my builds. Obviously, you can't ask Velpro or Mr. Gasket for 302 tunnel port intake gaskets, so I had to order some material, make them myself. Finishing up, factory distributor recurved Pertronix electronic module. Drew Pojednik did the carburetors for me. Those are 600 CFM Hollies. We used some 1-inch phenolic spacers for some extra horsey power on the dyno. New linkage. The correct powered by Ford chrome valve covers. New water neck, new bypass hose, obviously. So, solid build there. You all ready to hear it run?
Once it got going, it just wanted to go. And we were pulling it to 7,200 RPM, which, I have never done one of these engines before, and I wasn't really, I didn't know what to expect as far as what the head would do, because it was 100 and roughly 85 cc port, but a big cross-sectional area, and a 250 CFM port. So I didn't know how it would behave, and the camshaft was a hydraulic roller, 221, 233 at 50, so not a big cam. And to be honest, even with the 61 degrees of overlap that it had, it idled very, very mildly, and you can hear that in the video that I'm getting ready to play for you. I attributed that to basically each cylinder having its own runner. So in effect, it was kind of getting an individual runner type deal. This cam had, even though the specs are a little bit different, it had exactly the same amount of overlap that Nori's 289 did that we dynoed a few weeks ago. And that little engine had some thump to it at idle, but this one sounded more like a stocker. So could have been the way that the intake ports were letting the cylinders fill, could have been the runners, each cylinder getting its own runner. I don't know, but once it got going, it did not want to stop. And the amount of spring pressure we had with the springs that we were using, with the lifters that we were using, we were zipping this thing up to 7,200 all day long. No rear main seal leak. Yes, I give God thanks for that, that I didn't have to dip into the oil pan once I got it home. So this thing is, I just wiped it down, got all the fingerprints off the valve covers and that sort of thing, and it's ready to ship. So I'll be arranging freight and getting a crate made for the little feller this week. But let's go to the dyno sheet. So here is the moment you all been waiting for. So who was the closest on how much horsepower that the engine made? Let's start from the left-hand side here. So you can see we were making our pulls to 7 grand. On some subsequent pulls, we were going to 71, 7,200. Oil temperature, didn't do anything stupid. We were reading our water temp off the cooling tank, and we were pulling it at about 170, 180 degrees. Oil pressure did exactly what it's supposed to do, didn't drop off. Air fuel was in a good spot. If I were tuning this for someone around here in a car, I would probably lean it just a little bit. But there again, once you put an air cleaner on it, and especially since we're going from Kentucky to California on this engine, it's hard to say what the air fuel ratios will be there. So the carbs may need a little bit of tweaking. So, are you ready? Roughly 386 horsepower at 6,600 RPM. It did not lose but 3/4 of a horsepower at 68. 355 pound-feet of torque, down around 4,600. We were pulling it from about 3,500 RPM on. It didn't like to be loaded hard down low. It could have been because of the vacuum secondaries. It could have been just because it's a big honking port on a 312 cubic inch motor. But even at 3,600 RPM, look what we got: 230 horsepower, 330 pound-feet of torque. Any Fox body Mustang has less than that at peak. So, with some gear, with a manual transmission, this would be a really fun engine to have. And everything just looks really, really good. No valve float, no issues with anything there. Just a solid piece. And I'm going to show you a video of the electric water pump running. It's good to have on a race car or on a dyno engine because you can shut the engine down and you can cool the engine down very quickly like that. But we'll show you that first, and then we'll show a pull. So notice how in the dyno video, the engine is accelerating very smoothly, and then it hits a spot, and then it's gone. It's like, it's going. So solid little engine. I'm happy. Oil filter was spotless. Everything was perfect today. Very thankful for that. And we'll get this little guy crated up and shipped out to Mr. Mark. All right. Thank you guys for watching. Thank you for sticking with me on this entire build. I know it's been a long time coming, but sometimes we have to be patient, and we're rewarded with good things when we're patient. Y'all have a good weekend.
And there we have it. So very strong sounding engine, excellent performer, and pretty stout little guy for the displacement for factory pieces. Thank you guys for watching this video. If you like this video, if you like the format of it, let me know. I'm trying to find and trying to tweak and critique different methods and different formats so that I can get more viewing. So any feedback is appreciated. Hope you guys are having a good week. Hit that like button and that subscribe button. Helps me out. I appreciate that, and I'll see you soon.